Hello, everyone, and welcome back from the break. We're ready to get started with our final three presentations of the day. Next up, we have Hiroki Kato of JAXA presenting on the ROS and cFS system. Hiroki, it's all yours.
Yeah, thank you. Hi, my name is Hiroki Kato. So I'm working on the space robotics at JAXA. And so actually, there you go. So I'm presenting ROS and cFS system, RACS, using space robotics development, post open source activities and ROS2 integration. Next slide, please. So yeah, as everybody knows, we have more, we have to do more space exploration activities. So, we have to develop space robots. I'm currently working on the Martian Moon's exploration robotic sampler. So, that's a manipulator system, and currently we can't use ROS for the this development. So actually I need to drive for 7 hours last night to bring my some parts to home, but lots of trouble for the function testing. And we can't reuse software. We can't use lots of stuff. So we need to build software components from scratch. So that's that makes us difficult for the and expensive. So but space robotics missions would become much easier and cheaper if platform like ROS on-ground robotics is applied to space robotics, and the robotists using ROS can join to the space robotics. That would be great. So next slide, please. So
All right, appears we are having some technical difficulties with Hiroki's connection. And welcome back. I think you froze for a minute or so. Please continue. I apologize.
Can you hear me?
We can hear you now.
Good. And cost should go down and functionality should go up. So we have 200K of users of ROS, and we have now those two. Next, please. So, but the problem though is we can't use ROS for the critical spacecraft systems. So why not? So because that's not fault tolerant. It's no safety functions. And we had limited target processors for the ROS ones, but so only examples of ROS to use space robotics is one for the we had NASA Robonaut 2 and Astro-V. We had JAXA had Interval. So that's no critical system. So next, please. Why not using cFS? That's our concept. Next, please. So our proposal of RACS, which is ROS and cFS system. So why not connecting ROS, and we have space community people are using cFS. And we develop RACS in between, and then we could we are kind of assuming we could produce more space robotics missions. Next, please. So our proposal, so allow users, including ground robotics, to easily develop new applications for space robotics. So what's in RACS? So we have actually developed RACS-1. We actually presented this 2 years ago in this FSW. So we back then we were using ROS1 code conversion to bridge functionalities between current trusted space software, which is cFS. So we already have this piece of software in GitHub, and we have tested SOISOC MPU, which is developed in JAXA. So that's a space qualified hardware, which I'm going to show you a little bit of evaluation later. And also, we are currently developing RACS2, which is RACS for ROS2 support. So that's we are trying to aiming to use ROS for critical space systems like cFS does. And we are planning to for the flight evaluation at ISS in 2022. Next, please. So RACS1. So that's this worked for ROS1. So as you probably know, ROS1 can run only on Linux. So we needed to convert from ROS to cFS. That's one big challenge of this part. So and also we have developed the ROS cFS bridge, but the problem again is it can be used only in Linux. So yeah, we can still use this piece for the development of software. I mean ground testing. But the problem is, we cannot flight unless the software, hardware is, supported ROS1. So yeah, so that's a, limited benefit. So next, please. So now let me talk about a little bit of RACS1. Next, please. So yeah, here you go. So GitHub is there, and then yeah, we have uploaded this. I think 1 year ago. Next, please. So we have had evaluation on SOISOC MPU. So yeah, that's superior in radiation tolerance and the space qualified hardware. And we have developed engineering model of this hardware, and yeah, we are still developing for the flight modem, but we have borrowed this, and then we did some evaluation of RACS1. Next, please. So yeah, as we expected, so memory size evaluation is the table left, and yeah, it's it's almost very little bit for the RACS part. Or most of them was the CFE part of memory. So yeah, so that's addition is okay. And also we have evaluated overhead time delay evaluation, and yeah, so that's a few milliseconds order. So yeah, it wasn't too bad. This impact on the sending and receiving message. Okay, next, please. Okay, so I'm going to talk about RACS2. Next, please. So yeah, as you probably heard of this. ROS2 can run on non-Linux OS, including embedded system. So it's compatible with processors for space, and yeah, it builds on the top of the DDS and the RTPS as its middleware. So you know that means it's comparable to ROS publish, subscribe, and CFS message scheme. So, and also ROS2 communication quality is available due to DDS iteration in the network layer. So yeah, so that's good news. We have ROS2 by now. So we have developed RACS2. That's you know, connecting between ROS2 and CFS, and it can run on non-Linux processors. So it's possible to coexist with CFS. So now, yeah, thanks ROS2, we can aim to use ROS for the critical space system like CFS does. Okay, next please. So we have 3 steps of the we have mitigation of RACS2 development. So we have 3 steps of the development. So step 1, yeah, it's just, you know, why not just starting from the simple thing, which is, you know, bridge. So that's similar to RACS1 bridge. So, you know, bridging topics between ROS and CFS. Okay, yeah, that's simple. And also step 2, that's a new part. RACS2 extended DDS. So the functionality would be connecting ROS2 and CFS via DDS layer, and the unified DDS layer enabling to control QoS of the entire software system. So that means yeah, so yeah, why not connecting DDS and we can control the QoS. That's the whole concept of it. Then once it's connected, we can develop for the space qualified QoS. So the unified DDS layer enabling improvement for the space collocation. So that's a good news. And we are actually planning to develop till step 1 and step 2. So yeah, and we are planning to release this in summer of this year. Next, please. Okay, so bridge is pretty simple. So this is the architecture. So left side is we have CFE, CFS. On the right-hand side, we have ROS2. So yeah, and the applications layer is on top of them. We have CFS top modules, and we have ROS2 modules. And simply we can, what we can do is just, you know, they can be communicated. So yeah, so that's pretty simple. Just receiving topics and then just, you know, delivering to the JAXA module. Okay, next, please. So this is a second step. We are, as you can see, we have we can communicate ROS2 and CFS via DDS layer. So that's a you know, more direct approach. So that's yeah. Obviously, it's speeding up communication, and yes. So as I said repeatedly, it can be, you know, we can start. What's the word? Yeah, enable to control QoS of the entire software system. So that's a next step. Next, please. And yeah, so once it can be unified, then we can just control on one single QoS, and then yes, at the end of the day, we're gonna able to use the ROS system for the critical space system like cFS does. Okay, next, please. That's video. Does it work?
So I think we prefer not to show any YouTube videos. Is this embedded?
Okay, good. So so we are trying to launch interval 2. We mean JAXA. JAXA is trying to launch interval to the GEM ISS. So we are, well, that's not, inside of some ISS. We can, oops, excuse me. We are trying to do some evaluation of RACS and RACS2. We actually have launched interval 1 that's already in ISS. So this video is for the interval 1. So it's not much information. So you didn't miss anything. Okay, next, please. All right. Okay, so here's the end of my presentation. So summary, we have developed the ROS and cFS system. We call RACS, and we have developed RACS1 for the and that's available on GitHub. So just leave us comment and whatever if you are interested. And also we are trying to develop, we are developing RACS2. So that's, we have 3 steps, and then so at the end of the day, we are thinking we can use ROS system for the critical space system like cFS does. So so maybe space ROS guys can be very interested in our activities too. So maybe we can start conversation if it's possible. Also, we are also planning to flight evaluation at ISS in this year. Okay, thank you so much.
All right, thank you so much. I apologize for not playing the YouTube video. I will note that our presentation slides will be published as PDFs on our website tonight. So if anybody would like to go in and watch that video, you'll be able to get those slides and click on the link yourself.
Yeah, it's just interval 1 video. So that's you didn't miss anything.
Okay. All right. First question from the audience is, I believe CFE doesn't currently have quality of service built in. Is the CFE DDS open source? If not, is it from a specific vendor?
Right. That's true. So we have to pick up one of DDS, and then we have to utilize this to the for the cFS too. That's something we are trying to do for the step 2 of the part. I have to see my presentation to name it. Where did it go? Step 2. RACS2 extended DDS. So we are trying to implement that part. So we can use DDS we can use CFS on DDS.
Okay. Next question. What is the expected impact on performance after using a bridge on step 1?
Oh, step 1. Well, so good news. But so yeah, simply topics message can be go on back and forth. That's one one good start. But the problem though is the communication in between two systems are independent. So it's kind of difficult to guarantee everything as a whole software system. That's, I think, bottleneck of the step 1. But good news is, just for the functional test, it's just it's a good communication functionality to do bridge. So I think it's still very useful for whatever development purpose, or maybe just in case maybe it can provide redundancy and so forth. So yeah, I think that's a and also we have RACS1 for the this part. So we have experience on the developing this part. So yeah, we just say, yeah, why not just developing this? So it's there.
Okay, I'm going to give just a few more seconds, see if any other questions filter in. We've got a few minutes left.
Oh.
All right, Hiroki, thank you so much for attending today and signing in, especially early in the morning on your end of the world.
Yeah, no problem. Thank you.
Thank you.